Good morning, my dear students. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmatal, Kathmandu, and the Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 8, this is your science class, and in your science class we have been studying about the lesson light. Yes, and in our previous class we studied about refraction of light. Well, refraction means bending of light. Yes, when light enters from one medium to another medium, it bends. Okay, that was what we studied in our previous class. Now today we are going to study about specific cases of refraction of light. Okay, first case we are studying about glass slab. Okay, how does light refract when it passes through a glass slab? And then after we are going to study about refraction of light through water and the effects of refraction of light. Okay, that being, first effect is, you might have noticed this, when a stick is dipped in water it seems to be bent. That is the first effect. Okay, like let me show you something. Okay, please notice this image. You might have done like this. If you dip a pencil or stick in water, then at the surface of water it appears to be bent. Why does it happen? Okay, that we are going to study today, okay, with ray diagram. And then next point is, a pond appears shallower than its actual depth. This also we discussed in our previous class. Yes, okay, today we are going to write the reason for this, because many students say that, sir, we already understand the reason behind this, but when we have to write we do not know how to write. They complain like that. That's why these two questions, considering these two questions to be difficult to write, I have prepared the answer, okay, which you are going to take today. Okay, well, let's start from here. Let's begin from here. Refraction of light through a glass slab. Okay, so here okay, when light ray is in air, or it is coming from the source of light, then this light ray is called incident ray. Okay, when the light ray is coming from the source of light and it is still in air, this is incident ray, and the angle made by incident ray to normal is called angle of incidence. Angle of incidence. Now when light ray the point on the surface of glass slab at which the incident ray strikes is known as point of incidence, and at that point of incidence you can always draw a line, imaginary line, which is perpendicular to the surface of glass. Okay, so when light ray travels from air to glass, that means rarer medium to denser medium, it bends toward normal, isn't it? See, its usual path would be like this. Yes, its usual path would be like this. This is its usual path, but because of change in velocity it bends inward or outward. Inward or outward? Well, since its velocity decreases, it bends inward. Inward means toward the normal. Okay, inward also means that, it also means that, okay, velocity decreases also means that its angle of refraction also decreases. Okay, that's why this light ray bends toward normal. Okay, now after refraction the light ray is known as refracted ray. Again, that refracted ray also encounters the surface once again, because at this surface it has to come from glass slab out to air. So the light ray has to travel from glass into air. So the surface at which, the point on the surface at which this refracted ray strikes, that is second point of incidence. Yes, or you can also say point of emergence. That is also referred as point of emergence. Okay, point of emergence means that is the point from which light ray emerges out. Okay, point of emergence, you can say that also. The second point of incidence in a glass slab is known as point of emergence. Now at the point of emergence also you can draw a perpendicular imaginary line. Yes, and that is also normal. Okay, now here this angle acts as angle of incidence, which is equal to angle of refraction. That's why it is also written as R. Okay, now since light ray is traveling from glass to air, that means it is traveling from denser medium to rarer medium. Yes, light ray is traveling from denser medium to rarer medium. And what happens when light travels from denser medium to rarer medium? It bends away from normal. Well, it bends away from normal because its velocity increases and the angle also increases. Okay, that's why this angle is larger than this angle. Now this angle for this surface, this is angle of refraction, but for the whole system this is angle of emergence. Okay, and the light ray which has come out of glass slab, it is known as emergent ray. That is why if you backtrace this light ray, it will give you this point. Yes, if you backtrace this light ray, you will get to this position. Okay, that means to say, if the object was here, then you will not see the object here. Okay, you will not see the object here. Instead, or indeed, you will see this object somewhere else. Where will it see? You will see it here. Understood? Actually the object is here, but if you see through the glass slab, you will see the object here. And if you look at this spot, you will see nothing. You won't see this ball, this object through the glass slab. You will see the image of the object through glass slab. Understood? That is because of bending of light, because this emergent ray actually reaches your eye. Yes, this emergent ray reaches your eye, and your brain cannot calculate or cannot manipulate this bending of light. Your brain thinks that this light ray is coming straight from the source. Okay, that is why your brain manipulates that the object is here. See, here I'd like to say, what is real you cannot see. What you can see is not real. Okay, in Hindi we call it, yes, जो दिखता है वो होता नहीं, जो होता है वो दिखता नहीं. It's like that. What is real you cannot see, or you cannot see the reality. You cannot see the reality, and what is seen is not a reality. Okay, what is reality is not visible, and what is visible is not reality. Okay, anyway, now you can take note on this topic. Okay, see here, when light ray passes through a glass slab, it undergoes refraction twice. At first, light ray passes from air to glass. In that case, air is rarer medium. At this case, yes, air is rarer and glass is denser. Okay, and glass is denser medium. So light bends toward normal because the light ray is traveling from rarer to denser medium. Okay, so light bends toward normal. That is R is equals to I. In the second event, the refracted light again passes from glass to air. Here is the second event. The light ray again passes from glass to air. That means denser to rarer medium. Yes, in that case light ray bent away from normal. Okay, see, the refracted light again passes from glass to air as it emerges out. In that case, light ray is traveling from denser to rarer medium, so it bends away from normal. The light ray coming out of the slab is called emergent ray, and the angle made by emergent ray to the normal is called angle of emergence. So E is greater than R. In a perfect glass slab, incident ray and emergent ray are always parallel. Let us see, this angle of emergence and angle of incidence must be equal, so that the incident ray and emergent ray are parallel to each other. Understood? Okay, now you need to draw this much. Write this note and then draw this much. And if the question is asked, explain the refraction of light through a glass slab, then you have to give both. You have to write a description as well as diagram. Okay. Now let's go to next question. I've already told you a stick dipped in water seems to be bent. Why? Okay. Here I showed you how I showed you a diagram of pencil. Yes, a pencil which is being dipped in water, and what you can see there, what you can view, what you can observe there is when the pencil is inside water, dipped inside water, it bends. It seems to be bent at the surface of water. It actually does not bend. It only seems to be bent. If we take the pencil out, then again it looks straight. Okay, that means the pencil is actually not bent, but it seems to be bent. However, you cannot see the actual pencil here. Here, you are not seeing actual pencil. You are only seeing the real image of pencil. You are only seeing the image of pencil. Okay, you are only seeing the image of pencil. What you see actually is not that. Okay. Now look here. Suppose that this is a stick. Yes, this is the real stick. This is not. Yes, this is the real stick. But when you keep it in water, you do not see it like this. Indeed, you will see it like this. You will not see the real stick. You will see the image of stick. Okay, and how is that happening? Okay, let me delete it. How is that happening? See, this is a stick, yes, and from each point of stick, rays of light are being reflected. But we are going to consider only the tip of object. Okay, from the tip of object, millions of light rays are coming out, or millions of light rays are being reflected. But we cannot trace all of these light rays. We are going to trace only two of the light rays. Okay, one of the light ray is passing perpendicular through the surface. Yes, and according to rule, the light rays which is passing perpendicular to the surface does not undergo refraction. It simply passes straight. And the second light ray is passing by making some angle. Okay, here it is passing like this, and this is the point of incidence, and at the point of incidence you can draw a line, imaginary line, which is perpendicular to surface of water. Okay, this line is known as normal. Okay, in that case you can see the light rays traveling from denser medium to rarer medium, and when light ray travels from denser medium to rarer medium, it bends away from normal. Okay, it bends away from normal. So these two light rays, these two refracted light rays actually get to your eyes. Okay, so when your brain receives these light rays, your brain cannot manipulate this bending feature. Okay, instead your brain thinks that this light ray is coming from here. And how do you get this point? By back tracing this line. Okay, by back tracing this line you get to this point. That means the image of the tip of the stick is formed at this point. Okay, that's why you do see the stick bend at the interface like that. Understood? Now see the note. A stick appears to be bent when dipped in water because of refraction of light. The light rays reflected from the stick under water has to travel from water to air, that is denser medium to rarer medium. So reflected rays bend away from normal. That means angle of refraction is greater than angle of incidence. Hence, by back tracing the light ray, it appears to be coming from upper point. So actually light is coming from here, but it appears to be coming from here. Understood? Again, I take the note, pause the screen, pause the video, take the note, draw the diagram. I'm going to next feature. Okay, the last one, a pond appears shallower than its actual depth. You already know that it is also because of refraction of light, and the reasoning is same as above. See, a pond appears shallower than its actual depth because of refraction of light. Once again the same reason, the light rays reflected from the bottom of pond has to travel from water to air, that means denser medium to rarer medium. So reflected rays bend away from normal, that means angle of refraction is greater than angle of incidence. Hence by back tracing the light ray, it appears to be coming from upper point. Once again the diagram is same, only that instead of stick we keep bottom of pond. Yes, this is the bottom of pond, isn't it? And this is random point at the bottom of pond. From this point several light rays are being reflected, but we would trace only two of them. The first light ray is traveling perpendicularly, yes, perpendicularly to the surface. And you know, the light ray which is traveling perpendicularly to the surface do not undergo refraction. Okay, do not undergo refraction, it will simply go straight. And the light ray which is traveling by making certain angle to the normal, that means angle of incidence, this light ray has to travel from water to air, that means denser medium to rarer medium. And when light ray travels from denser to rarer medium, it bends away from normal, isn't it? So when your brain receives this light ray, your brain simply back traces it to find the source of this light ray. Yes, I've told you several times, your brain cannot manipulate the bending of light. Our brain does not understand the bending of light. Yes, that's why our brain thinks the light ray is coming from this point, and this point is obtained by back tracing this line. How to get this back tracing line? Just put your scale through this line and back trace it. Okay, now this is your image. That means the bottom of pond is actually here. It is here, but you will not see it here, you will see it here. You will not see the real bottom of pond, you will see the image of bottom of pond. Okay, that is why the apparent depth is less than real depth. Okay, apparent depth means what appears to be. Okay, that's why a pond appears shallower than its actual depth. Okay, okay, that's it for today. Okay, next time we will start our new lesson. For today I want you to submit your exercise. Doesn't matter from which publication, whichever book you have, you can use any publication book. Okay, whichever book you have, just use that book. Okay, and turn over the lesson light, read through thoroughly the lesson from the book, read thoroughly, read completely, and then do the exercise from the same book. Okay, and after doing that, take out the picture of the exercise you have done and send it to me through messenger. Okay, that's all for today. Thank you very much.